Hey everyone, welcome back. And so now we're going to look at, I'm just turning my color so that I have my color on. Now we're going to look at metabolic reactions. So in any given reaction, you have structures known as reactants. And so that's what these A and B would be. They'd be the reactants. And then you have substances known as products. And so C and D are products within a reaction. And so in this case, the reactants will produce the product. So what this says is this is the way the reaction is running. And so A and B produce some products of some sort. And so reactants are substances that participate in a reaction, and then the products are what we produce. They form as a result of the reaction. And so these could be any molecules. It doesn't matter. It's just showing you what they are, okay? So the term metabolism, because all of these are metabolic reactions, is the sum of all the chemical reactions that occur in a cell. So every single cell in our body metabolizes. Every single cell on Earth metabolizes. And these reactions can be broken into two major forms. So catabolic reactions. A catabolic reaction is a reaction in which we break down. This is an E, sorry. We're going to break down a large molecule into smaller subunits. And then we have anabolic reactions or anabolism. This is the buildup of a large molecule from small subunits. Okay, so these are reactions that tend to go together. Catabolic reactions, you take something large and you break it down. Anabolic reactions, you take something small, a lot of small things, and build something up. So they tend to occur together. You can break something down and build something else up. I always remember these. For me, the word cat, I always think of just cats in general. And cats like to jump on counters. And we often have glass on our counters, like just a drinking glass. And it gets pushed off, broke by cats. So catabolism is the breakdown of large molecules. Cats break things. So anabolism then is the opposite. I always remember anabolic steroids actually. And anabolic steroids are what build up muscle. So that's how I remember these two. So again, the definition of metabolism is the sum of all of the chemical reactions that occur in a cell. So let's just look at what this could look like if we're just talking about regular everyday items. Okay, so we're going to look at first an anabolic reaction. All right, so in an anabolic reaction, we take small subunits. So we have nuts, we have eggs, we have chocolate. So I'm going to just go out here. Butter and sugar, okay? Powder, flour, I guess. So there's all these different subunits. We put them all together with, I don't think we see on here milk. I'm sure there's milk and there's baking powder. We mix that all together and we put it in the oven, right? Add a little bit of energy and we produce this beautiful cake. Okay. And so these are all small subunits and we build up a larger molecule. Okay. So that's an anabolic reaction. So the opposite of this then would be catabolic reaction. In a catabolic reaction, we take, like that cake, and we eat it. So here you have a bunch of little kids eating cake. And all that sugar is going into their system. So they're breaking down that large molecule back into the smaller subunits. And this is going to then release energy. So remember, in the anabolic reaction, we took in some energy in the form of heat, the oven. In the catabolic reaction, we're releasing energy in the form of kids running around, acting crazy, and having fun. So this brings us to exergonic and endergonic reactions. So reactions can be considered exergonic or endergonic. So we have metabolic reactions, I'm going to put up here. We have those catabolic reactions, right? And we have anabolic. So metabolic reactions can also be considered exergonic. So exergonic reactions are spontaneous reactions and they release energy, which means the products have less energy than the reactants. So if we go back in this catabolic reaction here, we released energy and that energy drove these kids to be able to run around. What that means is that exergonic reactions are also catabolic reactions. And then we have endergonic reactions. Endergonic reactions require an input of energy. And so I'm going to just go back 2 slides ago. Right here, we had an input of energy, and here in the form of heat from the oven. Input of energy. And so that means that the product has more energy than the reactants. And so this requires an input of energy. This is an anabolic reaction. Okay. So anabolic reactions are endergonic reactions. Catabolic reactions are exergonic reactions. All of these are metabolic reactions. So I'm going to stop here. And yeah, we'll get into ATP in our next video. Bye.